Now let's see how to install the Geth. Geth is one of the client, the Ethereum client, where we can deploy the contracts, where we can connect our DApp applications, where we can work with the smart contracts, where we can do the transactions. So Geth is basically our Ethereum client. So in order to start with, we need to install the Geth. So we can get the Geth from this location, get.ethereum.org, and based upon your operating system type, we can install that particular Geth versions. So for if it is for Windows, it will be the exe file. So for Mac, you will be having the DMG disk image file. So similarly for the Linux, you have the installables. So if you want to know the various steps on how to install, just click on this install tab. It will have the environment specific or operating system specific steps to install the Geth. So it's a very simple process. Currently I'm not going to show you how to install the Geth because I have already installed the Geth. It's a very simple basic steps you need to follow to install the Geth. So once Geth is installed, we can verify the version, or we can verify whether the Geth is installed successfully or not, just by typing the command get space version. So it will give you the what version of the Geth it is installed. So I have installed the Geth very long back, so my version is 1.7.2, but now I think it's 1.8. It's the latest version. So when you install the Geth latest version, you will be having the what is the version you have installed on this on this details. So the next step is we are going to see how to create a private network, private chain. So what does it mean by the private chain? Okay, so let's see, you have a block B1, B2, B3, 3 blocks are there. So this is a private chain. So we are creating a chain, the blockchain, on our own network. So these blocks are just interlinked. The first block in the blockchain is called as a Genesis block. So whenever we are going to define or whenever we are going to create the blockchain, the first step is to define the Genesis block. Genesis block is nothing but you're basically the first block in the blockchain, and then based upon from that the simultaneously the consecutive blocks will be created. So if you take the Genesis block, the previous hash will be 0, or the head value, which will be equal to the current hash. So current hash or the generated hash. So the Genesis blocks, the head or the blockchain value will be equal to your the head and the hash, the Genesis block hash, block number, not the block number but the hash will be equal. So that is what the Genesis was. So the first step for creating the Genesis block is we need to create the JSON file. So we will see what is the steps and how to create a basic JSON file, so what it should contain, and we will see every other details. So I forgot to explain you about what this Ethereum client is, why we need to go for the Geth. So once we see what the Ethereum client is, then we will go for the how our Genesis block should look like and what are the parameters we need to be passed on the JSON file. So we will be seeing all these details. So the first step here is we need to see, this is the client, this is the node, this is your Geth actually, where it is nothing but your Ethereum client. So with this Ethereum client we can do so many transactions. Say for example, you can receive the block from other Ethereum clients because it's a network. So everything is deployed on the network. It's not just our one client, but there are so many Ethereum clients. So one Ethereum client can connect to the multiple Ethereum clients. So your Geth should have the capability to connect to other Ethereum clients. So that is what one of the basic or the major need for the Ethereum client. Then the next thing is you can validate your transactions. You can see how your transactions are, is it a valid transaction or not. then we can do the transactions. Like you can send some money, or you can send the transaction, or you can do whatever the transactions you want. Then you can deploy your smart contracts, you can execute the smart contracts, and similarly you will have the block explorer, where we can see all our transaction history as well as the transaction status and how many transactions are successfully mined. So for each of the transactions we have made, so the transaction will be initially in the unconfirmed state. So what does it mean by unconfirmed state? In the sense, whenever we are making the transactions, we need the Ethereum expects 6 confirmations. So once the six confirmations are made, then only our transaction is called as a valid transaction. So this is the important concept for while dealing with the double spending problem. See, double spending is one of the major problem in many transactions we have seen. So this double spending problem will be eliminated because of who gets the 6 confirmations, because we won't be getting all the 6 confirmation at a time. Suppose A is making the transaction, say a very simple example. In the bank account is transferring the money, say the bank account B1, so A is sending the money to C. Similarly, in the same bank account, B is sending the money to D. Say the bank is having the balance of $100. A is sending some $50 and B is sending some $30 at the same time. So which means my blockchain should have the updated results of the $20 remaining in the B1 in my bank account. But since both A and B are doing the transactions at the same time, so if suppose A is doing the $50 transaction, so if both are doing at the same time, so consider my transaction is somehow is not doing in the right way. So suppose it is shown the balance as 70 because B has sent the $30 and it is showing the balance as 70. So this kind of what do you say, this kind of problems can be eliminated in the eliminated in the blockchain while getting the 6 confirmations. So whoever is getting the 6 confirmations first, their transaction is considered to be the valid transaction. The remaining else transaction is considered to be the invalid transaction. So this is what the basic about the Ethereum client. Now we are going to see what is this Ethereum client is all about and what are the terminologies or what we will be using for the communication. So this is our initial DApp. Suppose in order for a DApp to communicate with the Ethereum client, there are 2 ways they can do. One is the RPC, remote procedure call, the IPC, inter-process communication. Another one is a JSON, which is the HTTP method. So when do we go for the HTTP and when do we go for the IPC connection? It's one of the important concepts we need to see. When both your DApp as well as Ethereum client both are residing on the same system or same node or same system or on the same network, not the network, same system, then we go for this IPC call. So inter-process communication, because this DApp will be running on the process 1, your Ethereum client will be running on the process 2. So for your P1 to be communicated with the process 2, so that is what the process 1 is communicating with the process 2 on your system, which is called as an inter-process communication. Suppose your DApp is on some other system on the network and your client or the Geth is on other system. So in order for this communication to take place, we use the HTTP communication. sorry, we use the HTTP communication. So this is the major difference, like why we are going for the IPC as well as why we are going for the HTTP. Now, so we are clear with this part. Now the next part we want to see is this one. So this is nothing but how your one Ethereum client is communicated with many Ethereum clients. So that is the Dev P2P is the protocol that usually the Ethereum client will follow to communicate from where one Ethereum client will be communicating with the other Ethereum clients. So it is usually on the TCP protocol, which is on the port 8546. So this is the port that is usually that is how one Ethereum client will be communicated with the other Ethereum client. Now the next step is, so we have so many consoles available, as well as not so many, we can connect the console as well as any DB to our client. So the DB, say the level DB or the NoSQL DB or the MongoDB. So we can connect up so many DBs with our Geth or with our client. Similarly, for each client we can have own console where we can write all our Java scripting or Web3 related scripting or any Java scripting based coding. We can do it on this console, and we can communicate with our Ethereum client. So this is the basic architecture of how our Ethereum is. This is the basic architecture of how our Ethereum how our Ethereum client is working. So the level DB is basically used to store your database. It's the lowest level and it's the most used level, most used DB in the Ethereum. But it's not mandatory to go for level DB always. We can use the NoSQL DB or MongoDB or whatever the DB we need to connect to, we can use. But it is always preferred to use the NoSQL kind of DB or not the relational DB, because relational DB you need to create if it is a relational DB, you need to have the table structure, you need to have the data in this particular table format, so which is little bit the old format. So in the Ethereum client we will go for the non-relational kind of data structures like a NoSQL, MongoDB, so which is easier to implement the you can store whatever you just need to create the particular DB structure, and we can pass it's all basically the JSON file which will be passed to your MongoDB or NoSQL DB, and from there it will be the records will be added in your database. So this is what the basic functionality of our Ethereum client.